Question 2. It asks us to draw a tangent to the curve at t equals 0, time equals 0. So we draw a tangent to this curve. It's got to touch at that point, touch at time 0. It's got to touch the curve there, and it's got to try and just touch and be equidistant, equal distance coming down here, not crossing the line at any point, so not too sharp, not too shallow, just touching, and be equidistant, equal distance either side with the curve. You get a little bit of leeway either way. Use the tangent to use the initial rate. So the initial rate is this rate here of the reaction. So you do that by doing the gradient. So you measure the height, which is 0.5. You measure the width, which is 10. So your answer is 0.5 divided by 10. It's actually a negative gradient because the line's coming down this way. If it were going back up the other way like that, it would be a positive gradient. This is a negative gradient. So it's minus 0.05, although you don't lose a mark for forgetting the fact that it's a negative gradient. So 0.05 is my initial rate here. Let's have a look at the second part of the question. The experiment was repeated at the same temperature with the same initial concentration of B. What that means is, if it's at the same temperature, the rate constant K doesn't change. Only changing temperature, that's the only thing that can change the rate constant. Nothing else can change the rate constant, only temperature. So if the temperature stayed the same, the rate constant K has stayed the same. What else has stayed the same? The initial concentration of B has stayed the same. So rate equals K, that stayed the same, A squared, concentration of A squared multiplied by the concentration of B, and B has stayed the same. It now says that it's 1.7 times greater, so the rate was 1.7 times larger than it was in the original experiment. So if the rate has gone up by 1.7 times, then the rate has gone up by 1.7 times 0.05. It's gone up 1.7 times this value. So A squared, since these other two are staying the same, K is staying the same and B is staying the same, A squared must have increased by 1.7 times as well. So if the rate's increased by 1.7 times and K is staying the same and B is staying the same, A squared has increased by 1.7 times. So how much has A changed by? A has changed by the square root 1.7. A has changed by 1.3 times what it was in the original experiment. Now in the first experiment, the concentration of A was 0.5 at that rate. The concentration was 0.5 of A. A's concentration was 0.5 there when the line touched the curve at time 0. So A initially, and the first experiment is 0.5. Now it's gone up by 1.3 times, so I'll multiply 0.5 by 1.3, 0.65, and it's to two significant figures because 1.7 is to two significant figures.